and welcome to PCB Chat. I'm your host, Mike Buetow. Today's podcast is sponsored by PCB Update, the free digital newsletter for the printed circuit industry. Visit the website at pcbupdate.com to subscribe. Our guest today is Brad Griffin. Brad is Product Manager Group Director at Cadence, where he has spent 16 years working on software for high-speed and physical design solutions for printed circuit boards and IC packages. He has been in the EDA industry since 1990, with companies like ViewLogic and Mentor Graphics. Welcome to PCB Chat, Brad.
Hey, thanks, Mike. It's great to be with PCB Chat.
So Brad's going to talk to us today about a new 3D electromagnetic simulation tool that Cadence is releasing. Before we get into that, however, why don't you take a moment to describe the problem that you see designers encountering today?
Yeah, that's a great intro, Mike. I appreciate that. Basically, what we're seeing is that there's some key industries where the speeds and the volume of the data is just increasing at an exponential level. You could take a look at data centers and the things that they're having to deal with new computing resources using PAM4 signaling at 56 gigabits per second and above, and the automotive industry and the challenges of being able to transfer data between the various ECUs and the data speeds potentially going up to a gigabit per second across two pair of wires, just where your impedance in your control is going to be very difficult to manage. And you take a look at industries like 5G and the decisions that you're going to have to make with all the data and the massive amount of data that's going to be processed at the edge node as well as at the data center. We just can't get past the fact that the volume of data is increasing. That means the speeds are going to have to increase, and that means that there's going to be challenges in removing those bottlenecks. We're looking at those challenges specifically pointing into the area of system-level signal integrity and system-level power integrity, and how we're going to model all the various pieces of interconnect that are going to be required to be able to simulate these systems before customers actually bring them to market. And so this is no longer just a single board problem or a single package problem. It's looking at the full system, especially in cases where you've got a rigid flex design. In the past, we might have looked at the individual boards between the rigid flex cables individually. Now we really have to look and see if power can be delivered across the full system. There may be high-speed connectors involved. There may be cables involved. So the amount of interconnect modeling required is just growing tremendously, which really sets the table for the need for a next-generation level 3D field solver.
How does Cadence propose to resolve that issue?
Well, that's a great question. One of the ways we've sort of looked at this is we look at the challenge of maybe 112G, and this is they're going to be the upcoming challenge in data centers. And so, Cadence has solutions around signal integrity and power integrity, and they have chip-level tool design tools, package-level design tools, PCB-level design tools. But when you look at something like 112G interconnect across the long reach, which can be as long as 100 centimeters, there's just going to be no margin for error as far as being able to make sure that signal can be recovered at the far end. As an example, you could look at the redistribution layer inside the chip, going into the package, going into the board, then 112G connector. These are the most complicated connectors that we've ever seen before. So they need to be modeled with extreme detail and merged with the printed circuit board to be able to make sure that transition from connect to board is able to be appropriately. What we've proposed at Cadence is that a solution that we think is going to address some of the market issues with speed and capacity. Because I think in general, people would use 3D field solvers on a regular basis if they could get their answers back in a reasonable amount of time. The challenge has always been, I'm going to have to be able to get the answer back today, so I need to cut this problem up into the smallest possible piece and take advantage of whatever computer resources I have to be able to resolve that and get a model back so I can perform my signal integrity or power integrity analysis. What Cadence has basically said is that most 3D field solvers, including the one that's previously been available from Cadence, are not really doing a good job of taking advantage of high-performance computing. And so what we did is we said, hey, we've been addressing this on the chip side in tools like Tempest and Voltus. we've been paralyzed in that problem, solving timing problems and power integrity problems in the chip side by doing world-class parallelization. So let's take that same parallelization technology and apply it to full-wave 3D field solvers. And so what we've come up with is something that actually takes advantage of all the resources, not just of one computer, but multiple computers. It allows you to scale back the memory requirements. One of the issues that people have always had with high-performance computing with 3D field solvers is because of the meshing that needs to be performed, is they've had to be able to make a copy of the design on each of the computers when they're trying to use multiple computers. Cadence doesn't need to do that. We actually, instead of having to make a copy, we can basically reduce the amount of memory on each computer. And so instead of having multiple terabyte machines, you could have multiple machines that are maybe a couple hundred gigabytes of memory requirements, and you can solve the problem much more effectively. So we're seeing 10x performance, unprecedented capacity, virtually unlimited capacity, and we're able to remove that requirement to actually have to slice the design up into a smaller piece. So instead of a pseudo 3D solution, it's a true 3D solution. And this is all achieved with the new product that we've announced called the Clarity 3D Solver.
So when you come up with that 10x number, is that based on real-world simulations against other publicly available field solvers?
That's a great question, Mike. So what we've been able to do is take, a number of different test cases, working closely with our customers, and compare it to what we're referring to as legacy field solver results. Again, we group our own technology from Cadence, the existing tool from Sigrity called Sigrity 3DM, in that category of legacy 3D field solvers. And quite honestly, we've seen that in general, that tool performance is on par with the other tools that are on the market. But all of those tools have this issue with parallelism across multiple computers. We have an example where we took a 112G connector and we mated that with a printed circuit board. And so then we did all the breakout routing on that printed circuit board. So the merged connector in PCB, which again, as I might have mentioned earlier, this is one of the most difficult problems to solve as a signal integrity engineer, because that transition from connector to board is just so imperative to get right at a speed like 112G that any sort of impedance discontinuity and you're going to blow it. You're not going to be able to meet the bit error rate requirements at the receiver. What we were able to do is take a look at running sort of an apples and apples comparison on the same number of cores in the same machine, and just right out of the gate, the Clarity 3D field solver had a 60% improvement. And then as we started to scale that up to more and more cores, up to 320 cores, certainly the legacy technology does not scale anything like the Clarity 3D field solver did. So we were able to get 12.3 times faster on this 112G connector PCB interface. And we've had a number of other test cases, Mike, that are, again, these are real customer designs, real customer input, and we're able to validate that it's quite common to see up to 10 times faster, even sometimes in this case with 12.3, even faster than 10 times. And this is just the beginning, because we're talking about going from 40 cores to 320 cores in this case. Because of the nearly linear scaling of Clarity, I think it won't be long till we start testing this more in the cloud with larger numbers of cores, and we'll be able to make claims of even faster than 10 times faster. And the true advantage here is the scalability. And I'll just make one other point that I think is really important to make, Mike, is that if you're not dealing with an environment where you have 320 cores of technology, it doesn't mean Clarity is not for you. First of all, Clarity's memory footprint is much lower. It's much more efficient than the previous field solvers. And it also has this advantage. It basically won't run out of memory. Users of these tools have this fear that if they don't cut the design down to the smallest possible size, their tool is going to run for hours and hours and then not complete. It's either going to crash or run out of memory. They're always concerned about that. But the Clarity 3D field solver, the way it's constructed, is it will use those resources. And if you only have, say, a 4-core machine with 64 gigabytes of memory, it'll use those resources. It'll very carefully go through and just keep sort of rotating through and using those resources till all the problem gets solved, and it will not crash. So it will take a lot longer than if you threw 320 cores at it. But even if you have like a 4-core machine, you will still get an answer. Pretty exciting technology that we think is going to help the user community that does interconnect modeling really advance their game in this area.
Now, Brad, is Clarity built on the Sigrity platform?
It's a combination of technology that a lot of it comes from Sigrity and a lot of it comes from our digital sign-off group. as I mentioned, the fact that we've been doing this parallelism within the Cadence environment for quite some time is people are in the IC side of things are very familiar with that. So now we've been able to take and we've certainly updated and refreshed. There's pieces that came from Sigrity. The meshing process is something that started with the original Sigrity technology, and it's been improved. The frequency suite that's part of this process to create the S parameter model, again, it started with the Sigrity technology and has been improved, and then we merged that together with the parallel processing from the digital sign-off group. That's the way that we started out the baseline for the Clarity 3D technology, and we've obviously advanced it to the point that we're seeing the kind of results that we're seeing right now.
Why don't you walk our listeners through some of the key features of Clarity?
The primary thing about Clarity is that it is an electromagnetic simulation tool. It's designed for the purpose of being able to take advantage of computer resources. So you'll effectively see the 10x performance with virtually unlimited capacity. And without a doubt, it needs to be mentioned, Mike, that there's no sacrifice on accuracy. So anybody running a full-wave 3D field solver is expecting their S parameters to match the same results that you see in the lab. So this idea of gold standard accuracy, we started out that from the very beginning. We can't sacrifice any accuracy for speed. That's been the goal from the beginning. So accuracy is key. The performance is extremely important. And so, as we've already mentioned, one of the key features is it's architected to be able to run on dozens, hundreds, potentially even thousands of CPUs to be able to resolve the problem much more efficiently. And this can either be on-site, on-premise, or through cloud-based solutions. And this ties in nicely with the fact that Cadence also announced the Cloud Burst program, which is going to make it much easier for Cadence customers to be able to take advantage of cloud resources. There'll be literally no involvement from their IT department. They just need to work with Cadence, take a day or two to get the whole thing set up, and then boom, their tools can be up and running within the cloud using the Cadence Cloud Burst solution. So Clarity and Cloud Burst coming out at the same time is no coincidence. It's really a move forward in that direction. And another key feature is, yes, this is a Cadence tool and is certainly able to take in data from all the Cadence implementation platforms, whether that be chip, IC package, or printed circuit board. But we're certainly open to reading data through industry standard formats like IPC 2581 to be able to read in other vendors' tools from the implementation side into the Clarity 3D solvers.
Okay, and Brad, I know you announced this week at CDNLive in the Silicon Valley. What was the reaction from folks who were attending?
It was extremely good. There was a keynote speech from Arista Networks where apparently they weren't aware that we were going to be announcing Clarity. And one of the things they asked him to put into his presentation was like, how can Cadence help them? And basically what he had in his presentation was they needed help on their 112G interfaces and being able to do model extraction on those 112G interfaces. And it was like, wow, okay, that came out.
Teed that up for you, huh?
I mean, I guess I can't say for sure that it wasn't teed up, but as a product marketing manager for the announcement, I thought to myself, well, that couldn't have worked out any better, could it? So that was pretty good. We also had a paper from Socionext America, who's been one of our sort of partners in this process, is going through. They do a lot of analysis of high-speed package designs, and so they had worked with us to put together a paper for a 56 gig interface for their one of their packages that they've worked on recently, and they just gave an outstanding presentation that talked about how they the process they typically run through using legacy field solvers, and what it was like when they were able to run through the same approach, but didn't have to do the model segmentation that they do, or the interconnect model segmentation they do with the legacy technology. And basically, they show the process is basically the whole methodology was about a 7.5x speed up in their solution. The presenter, Dan Lambalot from Socionext, basically says, I get to go home earlier now. So he was much happier. That room was packed, Mike. I couldn't believe it. The PCB track at CDNLive, let's be honest, CDNLive is mostly focused towards IC tools most of the time. And so we have a room that held about 60 people. Every seat was taken. Every standing room spot was taken for that presentation. So I would say that there was extremely high interest once this announcement came out.
Brad, as non-traditional OEMs get into chip design, how is this impacting the IC to package to board optimization process?
Yeah, so that's a great question. So, you're absolutely right. We're seeing more companies that have been traditionally, buying off-the-shelf components, doing their own SoC design now. And I think the thing that we're seeing and part of the reason is, they're trying to design these smaller geometries that can be more efficient with power and such. And so now they're going to be involved with it. Traditional PCB customers certainly been familiar with being able to model the interconnect of a board. So if we take somebody that's, say, involved in the data center industry, and they're looking at this 112G as their challenge, and they want to build their own chip to support that, certainly one of the idea of working with Cadence is going to be very exciting to them, because they'll be able to basically work with Cadence for the 112G IP, working with our IP group to be able to get that SerDes designed into their chip. And then when they're going to have to make sure they can meet the system requirements, the 112G long reach requirements, they're going to have to make sure that all the various pieces of interconnect between that high speed SerDes and from the transmitter, the receiver, that's all modeled very accurately. So Cadence has the ability to be able to support them all the way through, from the SerDes IP to the chip design, all the interconnect. So as we mentioned before, the interconnect at the chip includes a redistribution layer. Then you got to model the package and the board. So ultimately, if you want to be able to get that technology from starting point of the signal to endpoint through the connectors, everything's got to be modeled so accurately, or else the big risk, I think, Mike, is that you'll get to the lab and things don't work. And you say, okay, why didn't they work? Why didn't they show up in our simulations? It's probably because you took some of the classic shortcuts that people do in interconnect modeling. Maybe you used a quasi-static solver. Maybe you relied on a hybrid solver for something, or maybe you didn't optimize the interface between your connector and a PCB using a full-wave 3D field solver. You might have taken some of your traditional shortcuts. What I believe is going to happen now is that all the pieces are set up from Cadence to be able to deliver all the design position portions, including the IP. Then all the modeling is going to be able to done very accurately using full-wave 3D field solvers, at least certainly as the design progresses. Maybe early on you take some shortcuts, you use some hybrid solver techniques, but as the design gets closer to the point where you're going to be building a prototype, you're not going to have to worry about how long is it going to take to run this simulation. We have examples of customers, say, maybe using a DDR interface to get their sign-off level solution using a full-wave solver was taking them as long as 7 days to get the answer back. So Clarity with this 10x speed up is going to be able to turn that to, instead of a week, potentially an overnight simulation. We certainly have some examples working with our IP group at Cadence where we've been able to show that all the various pieces can be modeled accurately, so including the SerDes. So we have some abilities to model IBIS AMI models for the SerDes to be able to support the PAM4 signaling and the equalization associated with that. And we've been able to deliver papers at DesignCon and even another paper this week at CDNLive that really shows the correlation between the results you see on the scope from the silicon and the results you see in the simulation. So the simulation would have happened obviously weeks or even months before, predicting how the signal was going to look. If there was a problem, you can fix that problem then, instead of getting the lab finding, oh, it didn't work, and then seeing that you're going to have to go back and resolve. That's going to add weeks onto your schedule. So I think these challenges at 112G are, we've never seen anything like it. When you look at what the signal actually looks like before the equalization takes place at the receiver, the eye seems to be completely closed, but there's enough there that the clock and data recovery can pull that data out and recover it. So you need to be able to make sure that the data gets there as open as possible, and then System SI, the signal integrity tools from Sigrity, can help predict what that signal is going to look like. And we've seen extremely good correlation. I think customers are very impressed that we're being able to address the challenges at these literally bleeding edge speeds that the industry has never seen before.
Well, this is a great development, Brad. What's the availability schedule?
Clarity right now is still in the beta test process, so we've not released it to market yet, but probably, I shouldn't say probably, the plans are that within the coming quarter, that when we get to the early Q3, we'll have release versions of this available.
And how will the licensing look like?
That is a good question, Mike. Unfortunately, I don't have that 100% resolved at this point. We're still working that out. So the pricing and packaging is still under discussion at Cadence.
For listeners who want more information, where would they go?
We've done a great job of getting some collateral out onto the our Cadence.com website. If you look for our new system analysis group, which I think is an important thing that we probably didn't discuss yet, is that the Clarity, instead of being branded Sigrity, is being branded Clarity because this is the first tool that the Cadence system analysis group has brought to market. So Cadence has big plans in the system analysis area. That's why we've created a group that actually brought some of this IC technology and board and package level technology into the same research and development group. So you'll want to look on the Cadence website under system analysis, and then you'll find the page for Clarity, which will be the first of many products to come.
Brad, I know that using customer names is a sensitive subject, but are there any particular end customers that are running this through beta that you can share?
We do try to not go into a lot of details about customers in these sorts of discussions, but as I mentioned previously, we have the CDNLive paper from Soci America. That'll be available soon for your readers to find on our website. If they have a chance to look at our press release, though, they'll see that we had endorsements from this on this technology from two fairly well-known customers, I believe. First is Teradyne, who's a company that builds just unbelievably complex machines that do testing of printed circuit boards and ICs, and some of the boards that they develop are some of the most complicated designs we've ever seen, with over 30 layers to them, because they're testing boards and systems that have extremely high data rates associated with them. Their PCBs themselves have extremely high data rates, and so that means they've been using 3D field solvers for quite some time. And when we were able to show them the value of the Clarity 3D solver, they were happy to come and promote this for us. And the key nugget I take out of their quote is that the Clarity 3D solver has really opened up a new era of analysis for them, because now they can run dozens of simulations the time that it previously would take them to run one. We also had a great success working in Asia with HiSilicon. And they're more of a chip-focused division where they're doing IC design, but the chips are getting more and more complicated. They're putting them on interposers, and the idea of being able to look at the chip, the package, and the PCB as one subsystem was something that they were really excited about. So they were able to endorse the product, saying they were excited to see the breakthrough performance of the capacity, because again, this is a matter of there's all these different substrates in it being put into a single design. So the capacity introduced by the Clarity 3D solver, and they've been prepped on the idea that we have this system analysis group that will be doing more system level tools, and they're excited to see more about what's coming from Cadence in the future.
So those are two impressive endorsements. That's great to hear.
Thank you.
I want to remind listeners that today's podcast has been sponsored by PCB Update, the free digital newsletter for the printed circuit industry. Visit PCBUpdate.com to subscribe. And I'd like to thank our guest, Brad Griffin of Cadence.
Thank you, Mike. I really appreciate having the time to talk to you, and I can't wait to hear what your listeners have to say.
Thank you. For PCB Chat, this has been Mike Buetow. Have a nice day.